All right, so we have exponential and logarithmic equations and inequalities. So there's two types of exponential equations. So you have the type 1, which are the easier ones where you can easily rewrite them by powers of the same base, which is what we did in 5.3. And then type 2 is where you cannot rewrite them as the same base. So for example, 7 to the x equals 12, they do not have a power in common. So the general strategy is to take the logarithm or the natural logarithm of both sides and then use the power rule. There's a couple of different types that you're going to see here. So you have 3 types, and we're going to do an example of each of these, but in general, okay, when you cannot rewrite as powers of the same base, take the log of each side. Number 2, if you have 2 logarithms with the same base, you can cross out the logarithm if there's one on each side. And then if you have a logarithm on one side, then you would change it to exponential form and solve. So I'm going to show you examples of all of these. So we'll start with 7 to the x equals 12. So we cannot rewrite these as powers of the same base. So what we're going to do is take the logarithm of both sides. And it's typically more common to take the natural log, so we're going to go ahead and just do that. So what I mean by that is you're just going to write an ln in front of both of these. Then you're going to simplify that and take the power rule. Okay, so you're going to take this x and you're going to move it to the front of your natural log. So it's going to become x natural log 7 equals natural log 12. And then you're going to use your algebra strategies to solve for x. So this is x times the natural log of 7. So you're going to do the opposite of times, and you're going to divide. Natural log 7 cancels out over here, and you have x equals natural log 12 divided by natural log 7. Now you're going to have to answer these 2 ways. So this is the exact answer, and then you're going to want the approximate answer. The approximate answer, typically it says to round to 3 decimal places. So that's when you put this in your calculator. So if I put this in my calculator, I'm going to go natural log 12, close that parentheses, and divided by natural log 7, close the parentheses, and I get 1, we'll go 0.277. Okay, and we'll use the curly equal sign here because we rounded. Okay, so this is the ln 12 over ln 7 is your answer in terms of logarithms. And then the 1.277 is your approximate answer rounded to 2 decimal places. And you can always check it in the original problem. 7 to that power, so 7 to the second answer, equals 12. So number 3 is almost exactly the same, or sorry, number 2. 3 to the x equals 21. You cannot rewrite those as powers of the same base. Okay, even though 3 times 7 is 21, you're looking for exponent powers. Okay, so don't get that confused there. You're always looking for exponential roots. So if I followed the same pattern here, I would do natural log 3 to the x equals natural log 21. Then I would take the x, move it to the front. So I get x natural log 3 equals natural log 21, and then divide by my natural log 3. Okay, and be careful there because that doesn't just become natural log 7. Okay, it's natural log 21 divided by natural log 3. And then you would put this in your calculator as, let's see, and that would be 2.771. And I just want to see if it is the same as natural log 7, and it's not. So just be careful with that. You do not want to try and simplify that any further. Okay, so natural log 21 divided by natural log 3, 2.771. And then go ahead and check that. 3, 2, the power of your answer. Oh, I had natural log 7 there, sorry. 3 to the 2.771. I'm rounding here, so it's not going to be exact, but 20.99 would round to 21. There you go. Okay, now this is very similar. You're going to have bases of 2 and 3. You cannot write them as powers of the same base. So we're going to start, same thing, do the log or natural log of both sides. Let's just go ahead and do the log. Same thing, same procedures. So you're going to go log, and then you have 2 to the 3x plus 1 equals log 3 to the 4 minus x. Okay, then you would apply the power rule. So that means I'm going to take my exponents and put them in front. Okay, so that's going to give me this. I'm going to have 3x plus 1. I want to keep that in parentheses because it's more than one term. And then log 2 equals, then I have 4 minus x in parentheses, log 3. Notice these logs both have the same base, 10, because there's nothing there. Okay, so it's just log. All right, now what I want to do is I want to solve for x. So I'm using my algebra strategies, which would be then to distribute, since I have 2 terms in front of my logs. So that means I've got a little more work involved with this one. So I'm going to do 3x times log 2, which just becomes 3x log 2. And then 1 times log 2, which is just log 2. And then that equals 4 times log 3, 4 log 3, minus x times log 3, x log 3. Now, in order to solve algebraically, I want to get all of my x's on the same side. So that means I am going to take this plus log 2, I'm going to subtract it. Over on this side, I'm going to take this x log 3, and I'm going to add it over to the other side. So that's going to look like this. 3x log 2, then plus x log 3 equals 4 log 3 minus log 2. Okay, so I just moved this over here, this here. Now that I have all of my x's on the same side, I have 2 of them, I've got to get them together. So I'm going to factor them out as a GCF. So I'm just going to take the x and then make this in parentheses. So I've divided it out. I have 3 log 2 plus log 3. Okay, so I factored it out as a GCF. If I went backwards and distributed that, I'd be right back at this line here. So I know I did that right. Sorry, it looks like 31. There we go. All right, and then that will equal a 4 log 3 minus log 2. And then I can solve for x since I have one of them. So it's x times 3 log 2 plus log 3. So I will divide by all of this. And it cancels out. And then here is my answer in terms of logarithms. Putting in the calculator can be a little tricky when it's so much like this. So you want to be careful with parentheses and all of that stuff. The way that I would put this in is you want a parentheses around your numerator and your denominator, since there's more than one term in both. And then also, when you press log, it automatically gives you parentheses. So there's going to be these as well. Okay, so being careful with entering this. So let's go ahead, parentheses. Then I have 4 log 3, close that. Then minus log 2, close the log, and then close the numerator. Then divided by parentheses, 3 log 2, close the log, plus log 3, close the log, close the denominator. So we have that double parentheses there. And that gives you 1.165. And we'll use the curly equal sign for that one. Okay, and let's just go ahead and check that. So it was 2 to the 3x plus 1. So I'm just going to use the rounded version. So 2 to the 3 times 1.165 plus 1. That's going to give me 22.5. And then 3 to the 4 minus 1.165, 22.5. Okay, so when I check that, I know that I did that correctly, even though the decimals are not the same, because remember I rounded here. So as long as the first decimal is the same, it should be fine. Okay, so let's do another example like this. And we'll go ahead and do this one with natural log. Okay, so I'll place the natural log in front of both. So I'll have natural log 4 to the x minus 1 equals natural log 3 to the 2x. Okay, notice I put the x minus 1 in parentheses because it's two terms. You don't need to put the 2x in parentheses because it's only one term. Okay, then I'm going to bring my exponents to the front of my logarithms using the power rule. So it's going to give me x minus 1 natural log 4 equals 2x natural log 3. Then distribute the x, so x ln 4 minus natural log 4 equals 2x natural log 3. You can bring the x over here, or you can bring the 2 over here. Let's just bring the x over to the other side. Okay, so now we have on this side, we have a negative natural log 4. And then here I have two x's, so I'm going to take that one out as a GCF. So I'm going to go x and then parentheses 2 natural log 3 minus natural log 4. So I've taken that and divided that out as a GCF here. Okay, then I'm going to divide by the 2 natural log 3 minus natural log 4 on both sides. And that's my answer in terms of logarithms. And then we want the approximate answer. Okay, so again, you're going to want to give both. So here I'm going to go, I'm still going to do parentheses for the numerator. Negative natural log 4, close the log, close the numerator. Divided by parentheses 2 natural log 3, close the log, minus natural log 4, close the log, close the denominator. That's going to give me a negative 1.7, that would be 710. Okay, let's go ahead and check that. So let's see, 4 to the, I'm just going to put a second, answer minus 1. Okay, and then 3 to the 2 times negative 1.71. So 0.0233, 0.0233. We're good to go. All right, next type of logarithm, it already has the log in the problem. Okay, so when that happens, you do have to note the restrictions. Okay, so take each of these logarithms and get your restrictions, your domains, from these guys. So you've got x plus 6, greater than 0, x plus 2 is greater than 0, and x is greater than 0. Oopsies. Okay, so that would give you x is greater than negative 6, x is greater than negative 2, x is greater than 0. The one that we're going to want to take is the smallest number. I think I've got to check it in my calculator. I want to look at it just to remember because for some reason I'm drawing a blank. So we'll look at it in a second. Those are our restrictions. Okay, now there is more than one logarithm on the left side of the equal sign, so we want to make sure there's one of them, so we're going to condense. So with the condensing, this minus sign turns into division. So this becomes a log base 3, and then you have x plus 6 divided by x plus 2. Okay, and then that will equal log base 3 x. Now, because they're condensed, you can use the equality property, which is these logarithms both have the same base, and there's one on each side. So they cancel each other out. And then we can use algebra to solve. You have x plus 6 over x plus 2 equals x, which means we'll then multiply both sides by x plus 2. Okay, they'll cancel out over here. Over here, I will distribute. This will be x times x squared, x times 2, 2x. Then I have this x plus 6 here. I'll move everything to one side. I'll subtract this x and the 6. So I'll get 0 equals x squared plus x minus 6. Can I factor that? I can factor that, right? That's going to be x plus 3, x minus 2. 3 minus 2, 1. 3 times negative 2, 6. Okay. And that'll give me an x equals negative 3, positive 2. Pretty sure we got to throw out the negative 3 now that I think about it. Okay, then check it with your restrictions. So I think you want the one furthest to the right when we look at this. So if I want to put this in my calculator, I'm going to put it in Desmos because it's probably easier for me to write it in there. Let me see. So log I've got x plus 6 divided by x plus 2. Is it letting me put the base of my log in? No, so I have to use the change of base formula divided by log 3. If you have the 84, you can just put the log 3 in. So don't worry about that. All right, so that is this graph. And then we got another one was log. So log x divided by log 3. All right, so our answers are x equals negative 3 and 2. If I look at this graph, there's negative 3, and that is nowhere to be found on this graph. Okay, so I want, there's x equals 2, and that's where it actually intersects at that point. So that is the solution that I want. So when I'm noting my restrictions, I want the highest number. Okay, so you would just find the one furthest to the, well, you guys, I'm facing the wrong way. Find the one furthest to the right on this side. Okay, so I would say x has to be greater than 0 for me to keep it, which means negative 3 is not greater than 0. So that guy gets thrown out. So my answer is just x equals 2. Okay, and then if you ever get confused, you can always just look at the graph. Okay, so let's do another one like this. for example 6. All right, so, well, this doesn't have a logarithm on both sides, so it's not exactly like this. So what we're going to do here, you have a log just on one side. Let's note the restrictions first. So you've got 3x plus 2 is greater than 0. That's going to give you negative 2/3. X is greater than negative 2/3. And you have an x minus 1 is greater than 0, which means x has to be greater than 1. And so that's the one you're going to keep, the higher number. All right, so when I solve this, you want to get one logarithm. Okay, so this is going to combine using multiplication because of the plus sign. So we'll condense. So this is going to become log 3x plus 2, x minus 1 equals 1. So when you have the log on both sides, you cross them out. This time you're not crossing it out. You're going to apply the exponent rule, or your property, where log A, what we went over in 5.1, base, answer, exponent, you rewrite it in exponential form. Okay, so if I rewrite this in exponential form, my base is 10, because there was nothing there, so base would be 10. My answer, this is my answer, 3x plus 2 times x minus 1, and then my exponent is 1. Okay, so condense. Okay, then rewrite in exponential form. And then solve. All right, so if I multiply this out, let's see what we got. We've got 3x squared minus 3x plus 2x minus 2. So that's going to give us a 3x squared minus x minus 2 equals 10. So we'll subtract that 10 over. All right, so 3x squared minus x minus 12. So then we have to solve that. So, I don't know if we can factor it. What's 3 times 12 is negative 36. So I don't think that's going to work. Nothing multiplies to 36 and adds to negative 1. Did I do my multiplication correctly? Yeah. All right. So I guess let's do a quadratic formula here. Okay, so we've got negative 1. That's going to be a positive 1. Plus or minus, let's see here, negative 1 squared minus 4 times 3 times negative 12 over 2 times 3. So let's see, negative 1 squared is going to be 1 minus 4 times 3 is 12, so that's 144, I think. 4 times 3 times negative 12. Yeah, so 1 minus negative 144, which makes that 1 plus 144. So it's 145 underneath here. And then 6. So 1 plus or minus the square root of 145 over 6. Does 145 simplify? You might have a 9. Nope. I don't think it simplifies, so I think it might be able to stay like that. Now, I've got to throw one of them out, though, because I want it to be greater than positive 1. So the feeling when I subtract, I'm going to get a negative. So 1 minus the square root of 145 divided by 6 gives me a negative value. So that one I've got to throw out. But if I do 1 plus that value, then I'm okay. Yeah, it's greater than 1. So then I just throw out the negative. So 1 plus square root of 145 over 6. And we can take a look at this. Let's see here. So I would just put this in all on one side, like so. I would just go log 3x plus 2, x minus 1, and then minus 2. No, it was 1, right? Yeah. And then there's my graph. And you can see where it crosses the x-axis, right there and right there, which, when I did these in my calculator, is about that value, 2.09, a little bit off. Okay, pretty close. So you can take a look at that. Okay. Example 7, when you have E and Ln. So remember, E and Ln are going to be inverses of each other as well. So if you have an E in a problem, then you're going to use natural log to eliminate it. And if you have natural log in a problem, you're going to use E to eliminate it. Okay, so for this example here, you have, starting with an E, you're going to take the natural log of both sides. So you're just going to write your natural log in front of both terms. Okay, now E and Ln, when they're right next to each other like this, they're going to cancel each other out. So these guys are gone. So the exponent comes down. All right, now you want to isolate natural log x, because that x is attached to this natural log. You can't divide by negative 2 ln, because there's nothing after the ln. Okay, so I'm going to divide by negative 2. So this gives me ln x equals natural log 1/16 divided by negative 2. Okay, now, since you want to get rid of the ln so you can find out what x is, you are going to take E on both sides. Okay, so you're going to take this E here, you're going to write it on both sides like that. And now the E and the ln next to each other cancel each other out. You get x equals this whole mumble jumble right here. You can put that in our calculator. This is x equals E to the ln 1/16 divided by negative 2. Let's find out what that is. So we put that in our calculator. You go second E, and then in there you've got your numerator and your denominator. So I'm going to do parentheses, natural log 1 divided by 16, close the log, close the numerator, and then divided by negative 2. I don't know if I needed all those parentheses. Just trying to be safe. Oh, I get 4. I get 4 there. Let's see if I can do it without it. Should be probably okay here. Yep, so I get 4. So I didn't need the extra parentheses for that one, but there you just get 4. So you don't actually need the curly brackets because you're not rounding. So the answer there is 4. And then just go ahead and check. So you have E to the negative 2 ln 4 gives you 0.0625, which should be 1/16. 1/16. All right, so you're using E and ln to cancel each other out. We got one more example of this, and then I'll let you guys try some. All right, so for this one, you have E in the problem. So first try an isolate. Sorry. Okay. Okay. All right, so let's try and isolate that. So just like if this were an x, I'm going to subtract a 4 from both sides. That's going to give me 5e to the 5x equals 6. I'm going to divide by 5. I've got e to the 5x equals 6 over 5. Okay, now this is isolated, so now I'm going to do my ln on both sides. So once e is isolated, you do natural log on both sides. Now the natural log and e right next to each other will cancel each other out. And this 5x will come down. 5x equals natural log 6/5. And then we can solve for x. So we'll divide by 5. To get x equals natural log of 6/5 divided by 5. So we can go ahead and find that. And that's going to give you 0.036. And if we go ahead and check that, so 5e to the 5 times my answer, and then plus 4, gives me 10. Okay, so there's some practice problems for you guys to work on. I'll give you a few minutes to work on these, and then we'll go over them. Okay, let's go ahead and take a look at these. So for the first one, you're going to condense on both sides. So what that would look like is you're going to have a log a, and then it would be x minus 4 divided by x plus 11 equals log a, and then x minus 5 divided by x plus 6. Okay. Oh, we should probably check our restrictions here. So this would be x greater than 4, negative 11, 5, and negative 6. So this is the highest number here. So I'm thinking x has to be greater than 5. Okay. All right. So now what we want to do is you have log a on both sides, so you can cross those out. So this is just going to be cross multiplication problem. We have x minus 4 times x, or over x plus 11 equals x minus 5 times x plus 6. So let's just cross multiply. So x minus 4 times x plus 6. And then equals x minus 5 times x plus 11. Okay, cross multiply. That was that circle. Let's refix that. Okay. All right, so that means we've got to multiply everything out. So let's see here. This is going to be x squared plus 6x minus 4x minus 24. So x squared plus 2x minus 24. Then on this side, I'm going to get x squared plus 11x minus 5x minus 55. That's going to give me x squared plus 6x minus 55. And then let's go ahead and solve for x. So if I go to subtract x squared on both sides, they happen to cancel each other out on both. And then let's say I go over here and I'll subtract 6x. That's going to give me a negative 4x minus 24 equals negative 55. And let's see, I'll add 24. So that's going to give me negative 4x equals negative 55 plus 24, which I can't do on top of my head. Thank you. So, well, negative 31. Can I get negative 31? Okay, negative 31. That's okay. And then we'll divide both sides by negative 4. So that's going to give me x equals positive 31 over 4, which should be 7.75, I believe, which is greater than 5. So that's cool. We can accept it. All right, let's take a look at number 2. So for number 2, we've got logs on one side. So let's go ahead and get this into one log. And it looks like when I do that here, I can't quite do it yet because I've got this 2 right here in front. So I'm going to first take that and move it over here. This is going to be log 3 x squared plus log 3 x squared equals 8. Okay, now what I'm going to do is now I'm going to combine these using multiplication. So this is going to become log 3, and this is x squared times x squared, which is x to the 4th. So I'm just going to make that x to the 4th. Okay, then I'm going to convert it to exponential form. So my base is 3. My answer is x to the 4th. My exponent is 8. Okay, and then I would do 3 to the 8th. Let's find out what that is. 6,561. And then we'll take the 4th root of that. Okay, so find the 4th root of that. We are going to go 4 math and x root 6561, and that'll give us 9. Yeah. If you get the same answer, then no, it should be okay. Because then you would just divide it and make that 4. Yeah, that's fine. Okay, now number 3, you're taking a formula that we applied in, or we learned in this chapter, section 5.3. But this is really like, why are we doing this, right? So how can I apply this? You can actually use logarithms to solve financial formulas. So for example, if you purchase a home for $150,000 and the price of real estate steadily rises at 5% per year, how long do you need to own the home to profit $50,000 off of your original investment? So that is your interest formula, which is this formula right here. Okay, we are solving for time. So we're solving for an exponent. So you use logarithms to solve for exponents. So to profit $50,000, I would need the amount of the home to be worth $200,000 because I bought it for $150,000. So that would be my A. My principal, my original amount is $150,000. I am rising at a rate of 5%, and it's just once a year, so my N is 1. And I want to find 1 times T, so that's just going to be T. Okay, so if I just simplify this down just, I think we're at 15,000. Yeah. I simplify this down just a little bit. I'm going to have 200,000 equals 150,000, and then 1.05 to the T. So to solve for the T, what I'm going to do is isolate the exponential expression. So I'm going to divide both sides by 150,000. Okay, so 200,000 divided by 150,000 is going to give you 1.3 repeating. Or if we wanted to make this a fraction, I guess we could. 4/3. Whichever way you do it is fine. Equals 1.05 to the T. Now all this is are 2 bases that cannot be written as powers of the same base. So we take the log on each side. So let's go ahead and we'll do natural log on each side. Okay, then we will bring the T in front here. So this will be natural log 4/3 equals T, natural log 1.05, and then we'll solve for T. So divide both sides by natural log 1.05. And then of course you're not going to answer this question that way because we want actual time frame. So we would go here, natural log 4 divided by 3 divided by natural log 1.05. And that is going to give you 5.896 years. Okay, so it'll take almost 6 years, okay, to profit $50,000. Now that's, of course, not counting the payments that you're making in that time, but just for the value of the home to increase $50,000. Okay. Let me save that.